Well, thank you so much for being here. This is, I think, a very interesting topic. I think we're seeing a lot right now and in our future for this type of technology. And I just want to welcome you to our virtual academy this year. We are streaming live on all our social medias, and we also have many participants waiting in the wing. So I'm going to hand over the mic to you, Mr. Pompilian, and say welcome, and we look forward to hearing your message today.
Yes, thank you, Heather. Actually, I'd like to transmit my thanks to all the organizers of this, academy. Interestingly enough, I've been part of this at the very beginning of it, starting in 1990 and up to 1995. It was a completely different type of event at that time. And I was happy when Sorin contacted me and asked me if I can contribute to this, year virtual edition of the Summer Academy. So the subject for today, as we all know, are the autonomous vehicles, and with a very interesting title I choose for the topic, meaning who's afraid of autonomous cars. Now, I did put together a few slides, which I can use as material going through the discussion. Right? If I can actually start sharing that, I'm gonna click the share button, and I'm gonna be commuting back and forth between.
Okay, sounds good. I'll let you know when we
between
can
the live
see it.
and the slides I have prepared.
Yeah.
Okay.
Yes, sounds great.
Okay. So first of all, first of all, a little bit of introduction about myself. Anyway, I think. Can you see my screen?
Yes, we can
Yes,
see
we
your
can.
screen now.
Yeah. So I mean, I have many friends in that have been joining this camp for years. I have many friends, which I think they're part of this discussion. With many of them, I haven't talked or met in years. Um, Currently, I'm actually living in Michigan, United States. I'm working in the field of the autonomous vehicles as a design and engineering director, and I actually am a project lead for one of the, those level 4, and we'll talk about what level 4 is later in the presentation, computers. With about 15 years of experience in automotive electronics and a few patents actually awarded by the US Patent Office in the field. Now, the question is, let me try to see if I can, if you can find a better way of sharing it. If I can, yeah, share the screen actually. And I think this is better. So the first question is, should we be afraid of autonomous cars? It's anybody can can answer if we should or should not. Now,
Well, I think I have a little bit of fear. Maybe some people do, based on the testing and stuff that's been done, and the worries that people might have when they're not in control of a vehicle. So I would say I'm a little fearful. Yeah.
So talking about the testing, do you actually recognize this, or anybody recognizes this picture? Yeah, I mean, it shows a guy which is really scared, and I apologize for starting like this, but
the guy that's scared to death in the vehicle.
yes.
Yes, I do.
Okay, so let me actually try to run a video that that people might know. I have seen it in the past. So and again, we have the disclaimer here. The video is from ABC News, and you will recognize actually what happened. I don't know if the video streams very well through Zoom. So this is actually a test done with a Uber car in 2017. And it was the first test ever when a person was killed by a car in autonomous mode, in full autonomy. And yeah, you know, the image is of the guy who actually says that he's gonna hit the you know the person riding the bike. So going back to the question is, yeah, we might have a reason to be afraid of autonomous cars. Well, we know that technology is not there. We know that mix-ups are happening all the time. We know that through the progression of science and technology, there were accidents, right? In any industry, in nuclear industry, in, you know, how many people died trying to build and fly an airplane, right? How many people died trying to fly to the moon? So yeah, I mean, we were afraid at some point of a new thing, but we moved on. So the other videos I have here, and I can leave them later for for people to see. It's a couple of very famous Tesla accident, where Tesla, it's a different type of autonomous cars. It's not a full, it doesn't run full autonomy, right? So now, for everybody to understand, because I did have discussion with friends saying, we know what's autonomous driving. My car can do this. My car, I push a button and can keep the lane. So this being said, the Society of Automotive Engineers have defined a standard for driving automation, right? And this I pretty much would clarify what the features that we're seeing every day in the vehicles that we drive every day are part of what level of autonomy, right? So of course, no automation, it's zero autonomy. The driver performs all driving tasks. And this reminds me the year when you know, I used to drive my first vehicle. So it was a Dacia 1310 made in 1989. So level zero. The level one, which is driver assistance, means the the person, the people, drives the car or drive the car, but it has feature that will help the driver. Best example of this is, let's say, a rear view camera. Now it had become standard in every cars. You know, parking assist, where you look at the screen in your, you know, head consoles, the center console, and you see it. Or maybe the blind spot warning, where you have, you know, the little lights on the rear view mirrors, and then we'll try to change the lane without signaling, or change the lane, it's a car on the other lane, it's, you know, the system bips or, you know, lights up LED on the mirror. So this is a driver assistance, right? Is driver has full control, but just uses some of the things that are embedded in the design of the car to help him drive. Level 2 is partial automations, with when the vehicle has combined automated functions, but the driver must at all times be engaged. Meaning, you know, you keep your hands on the wheel, you keep your eye on the road, and you keep your foot on top of the brake or on top of the acceleration. And the level 3 is actually when you give the car the control when you are not necessarily required to keep your hands on the wheel. Like if you see on the pictures here, the pictorial, it's only one hand of the wheel, but the driver needs to be at all time prepared to take control. And it's been a very interesting discussion in between, for example, Tesla, because we've talked about the autopilot in Tesla. Is a level 2 or is a level 3? Right. So some people think it's a level 3, which is not. right? That's why the accidents that didn't run to the videos, but we all know happened when cars, for example, hit a truck which was across the main road. That's because, you know, the driver thought, yeah, car is taking care, but actually it was a level 2 system, or he should have hands on the wheel and foot on top of the brake, right? The problem with the level 3, and there are many companies out there trying to do this, Volvo, Audi, Honda, they said they're going to come up with level 3 cars this year. The problem with level 3 is that there have been studies done, psychological studies, where if the driver is completely disconnected from what's going on around, it doesn't have continuous awareness. It takes, if I remember the numbers well, it takes anywhere from like 3 seconds to 7 seconds to regain the control, which means in some cases it's going to be too late. I mean, you've seen the video. It's too late to hit the brake and stop the car in time. And from what I know, and many OEMs that are reconsidering actually giving up on the level 3 autonomy and going straight to level 4 or 5. And the presentation that I'm going to continue to focus today is actually focused on this level 4 or 5, and for ease of, you know, of presentation, I'm going to just call it level 4 plus. So what it is, the vehicle is capable of performing all functions under certain conditions. The driver might have the option to control the vehicle. So this car still has steering wheel, still has pedals for gas and brakes, still have levers for signaling left and right, right? But yeah, it's able, the car is able to drive itself. Why it says under certain conditions? Because as we could see later on the challenges, the environment, it's a huge factor. Which is challenging this level 4, level 5 automation. And full automation is where it's a full autonomous robot. The car, it's an autonomous robot. It doesn't have, it can perform by itself under all conditions, and the driver may have the option to control. The problem is that what I've seen currently proposed, you know, by different companies as concepts, including, you know, Cruise Automation, GM, including some Volvo concepts, including other companies, it's pretty much a car that doesn't look like a car. It has no usual controls. The seats are facing each other. It's like you are in a cabin on a, you know, first class in a whatever, in a train. So here there is a pretty much the same slide, which a little bit of more details. What it gives some feature examples, right? Not sure if I need to go through this. I kind of explain why talking about the levels of autonomy. So topic sharing for a moment. And coming back live. Is any questions so far? I cannot
see something
hear
in the
you.
Q&A, if I can read this to you. So there's a question from Claudio, and it says, who is managing the database running the cars? Can anyone take over remotely or mess up the commands like in so many science fiction movies?
The answer is yes. One of the problems with this autonomous cars, and I was prepared to actually explain a bit later on, it can become the perfect weapon, like for a terrorist group.
I imagine.
So the car is the car is connected. The car is connected to through various means to the environment, right? I mean, it's connected through, it's a system called V2X, which is vehicle to X, which is everything, right? can be other vehicles, can be infrastructure, right? Can be satellites, right? We have Wi-Fi connections. We have, most of these cars are planned to be, and it's like some of the cars that we already have right now on the road, right? They're called, they have a feature which is called OTA, which is over-the-air updates, meaning when you park it on your driveway, it connects to an Wi-Fi, to your house Wi-Fi, and all the software updates for all the controllers in the car are done overnight while you're sleeping, right? Well, somebody can of course hack that. Why? And that's why one interesting thing, these cars or these designs come with what to call it, like really strict requirements for cybersecurity. And usually it's an analysis which is done and look at all the access to the computer through the wireless connection, also through the wired connection, and we're putting in place all kinds of methods to kind of stop the, the breaking in into the box. And can be various software encryptions, can be hardware modules, can be whatever it takes. So yes, the answer is yes, it's possible. Okay, so
Okay,
moving
thank you
on.
for that.
Yeah, no problem. Moving on. A little bit of a history of, but brief history in images. Going back to the presentation. Okay. This is some cars that. Give me just a second. There's some cars which are part of the. At this moment, some of them ancient history of the level 4 plus autonomy. So Google actually has started doing studies on autonomy since 2008, 2009. Very secretly, I think they used some Acura vehicle at the time. But then they did build as called Google Firefly in 2015, which is supposed to be a full autonomous cars without steering wheel and pedals. And since then, they accumulated, millions of miles of driving in full autonomy mode. Pretty much in the same time, Baidu, who's the Google of China, did use a BMW car fitted with sensors and everything else, and started collecting and doing tests on the roads. And so the picture is pretty much 2005. Then one of the early companies, it was Uber. And they used some Ford Fusion vehicles, with a sensor stack and some computers inside. They started autonomous driving in Pittsburgh. And actually, I was in one of these cars back in, I think it was either late fall 2016 or early 2017. And it was an extremely interesting experience to see how the car reacts in autonomous mode and, with the other cars and participants to the traffic, right? Pretty much same time was Cruise Automation that was acquired by GM. That started testing on a full autonomy mode. Then Google moved. Well, Google, which is now Alphabet, split their autonomous driving division because they wanted to actually make money out of it, and created Waymo. And this is actually a car which is based on a Chrysler Pacifica base car, who's already doing commercial taxi service in some very well geographically bounded areas in some cities in the United States. I think they started in Phoenix, Arizona, if I'm not mistaken. And the latest I knew, this car still had a safety driver or a test driver. So it was pretty much somebody sitting at the steering wheel and doing nothing, but just collecting data and being able to take the control if something bad was about to happen. More recently, Argo AI, it's Pittsburgh-based company, was acquired by Ford and they do have a program of going to full autonomy, uh, very soon. Now, there are many other examples. I want you to just try to fit a few of them in one page. Now, I think we can go a little bit into more deep in the technical details. Hopefully, I won't go too deep, and please let me know if I do. I might be carried away. But pretty much the discussion is how actually we achieve autonomy. How can you take a base car and making it a robot car? Right? It's a little bit similar if you think about the car even nowadays that we drive. It's like a typical example of the control system, right? Where the controller part and the sensing part is done by the human driver. So how we achieve this? Like we take a base car that has sensors. I mean, it has braking, sure. It has a local microcontroller that controls the brakes with sensor and actuators. We have other chassis type of which is like suspension, and they have sensor, they have actuators. We have steering wheel. We have powertrain, which is the engine or the whatever motors in case of EVs. The transmission, the gearbox, name it. Right? Now this is the base car. Now at the top level, we need to put sensors. And the sensors that are used right now to replace the human, biological built-in sensors are the cameras, the Lidar, the radar, ultrasonic sensors, and interestingly enough, more recently I've seen coming into this, I've seen microphones and exterior microphones. And, it was an interesting question. So why you need microphones? And it's pretty easy to give an answer, because while you drive, you also hear, right? You hear honks, which is maybe not important. You disregard and you keep going or not. But what's very important are the emergency vehicles, are the police vehicles, fire trucks, ambulances, which in a busy traffic environment, right? You don't see them, or you don't see them even in your mirrors early enough to be able to pull over, but actually you hear them, right? You hear them, and you prepare yourself to pull over and let them go, right? And this is one thing that actually the people in this industry realize, that actually need microphone. And it was funny because microphone actually means recognition of the sound, right? So now combining the base car and combining the sensors, there are a few things that you have to do. You have to do recognition and classification, and this is what the human brain does always. The difference is the human brain is wired such a way that this recognition and classification is done extremely fast, and we don't even realize. There are years and years built in our neural paths that drive recognizing an image right away, which in case of programming machine to do that is not that easy. So you pretty much use the information from the sensors and build some kind of a virtual environment that it's a exact enough representation of the reality around the car. Yeah, and based on that, and based on a maps and path planning, you actually make decisions to control the powertrain, to control the steering, to control the brakes, to control other parts in the car. Right? Meaning, yeah, you turn left, you turn right, you stop, you go, you accelerate. Right? So this is pretty much how we achieve autonomy. It's like building a system, an autonomous system. It's pretty much a system that from. I actually graduated automation. So everybody who knows automation knows what I'm talking about. Stopping sharing for a little while and going back to the live stream. Any more questions so far?
Let me check the Q&A right here as we're going back to the live stream. Some of these, yes, I do see one. If you can hear me okay, if my mic's okay. It
Yes.
says some of these cars use rare, I think it says metals in the battery manufacturing process. Will this approach put more pressure on mining such metals? Great question.
Well, it's it's a long discussion because there's something. Yeah, no, it's a good question. One trend I've seen, right, is putting this. Well, let me be clear. A system like this can burn anywhere around between, let's say, 1,500 watts to maybe 2 or 3 kilowatts of power.
Mm.
They're very power-hungry devices, and we'll see later on why, right? But and curiously enough, I've seen a trend when the car manufacturer, the company working, they're putting this into the electric vehicles. So it's pretty much doubling the demand for power in electric vehicle. Like the vehicle doesn't produce power like burning anything else, like a gas, you know, ignition gas engine like a normal car. So yeah, the demand for batteries is going to be increasing. The demand for batteries more and more efficient is increasing. Now, about putting the pressure on the mining industry, I'm not sure if I can answer because I'm not a mining expert and I really know how how this metal and how many will end up in the batteries, and I know how much pressure. I mean, you can imagine these batteries don't have tons of, but it might be. But this is an interesting trend I realized, where people are putting these systems into electric vehicles. Honestly, for myself, doesn't make sense. Just because you kind of reduce the range of the vehicles, and then if you use this as robotaxis, you're gonna spend a lot of time by recharging them instead of pretty much making money being on the road. Now, in the same time, I understand that this helps with the environment, and always it's some type of golden mean somewhere in, you know, the Waymo vehicles that, you know, the Chrysler Pacifica that you've seen used by Google right now, it's actually a hybrid, not a full electric. And to me, makes sense more than being a full electric. Okay. So if no more questions, yeah, we're gonna move on.
Yeah,
Good question.
hopefully you would think that the technologies that go into building this, and hopefully they have diverse teams that look at all these issues, and hopefully the technologies sort of mirror each other in development, so that, you know, alternative energies and ways to you know, power and all these types of things kind of go hand in hand as you're fine-tuning all the automations for the vehicle itself, hopefully.
Oh no, they actually do, and you know, companies like Tesla are investing a lot of money in finding new battery technology.
Yeah, new ways for batteries and all that kind of stuff.
Which will
I
be
know we've come a long
efficient.
way, but I think we still have you know, ways to go. But yeah,
true. And at the end of the day, it's always a market pressure, right? Now the push for this full autonomous cars, it has behind an economic pressure, right? I mean, think about everybody has a car nowadays, right? Well, how much is everybody driving its car every day? I drive my, no, let's say before the COVID-19, because right now I almost drive, I'm not driving it at all. But before that, when I was commuting to work, maybe 2 hours a day.
couple hours. I would
Yeah,
say
couple
probably
hours.
for most people a day.
Yeah, yeah. So for the rest, the car was rotting on the driveway or on the garage.
I'm saving
And
a
you have,
lot in fuel money at the moment.
yeah,
That's for
and it's not
yeah.
only fuel, but the insurance.
Mm, good point.
Yeah. So actually, this is driven by a changing a little bit the mindset about mobility in general, right? This is where, for example, companies like Uber or Lyft, they had a huge success because they did it was a paradigm shift for the mobility, right? Now this is the next step. Yeah, Uber still has a driver. That driver has to rest, right? That driver drives a car for I don't know 6, 8, 10 hours a day. Now one of these robotaxis can drive for 20, 22 hours a day. You need a couple of hours for uh, regular maintenance, mechanical checkups, charging, or downloading the data. Because actually, those cars are could are making can make money by downloading data. You know, the state of the roads, the whatever something breaks, the mapping, continuously mapping, uh, marketing, right? So there are many uses of these cars beyond just transporting people. But yeah, and it's actually a market pressure that drives toward this, and there are billions and billions and billions in dollars. If I'm not mistaken, I remember a number. I think as of last year or as of this year, there have been close to $50 billion invested in this technology. So let's move on with my next few slides here. And Heather, please let me know how is
Yes, when
the
I see it
time?
up here.
Yeah, no,
Okay.
how are the
Oh
time?
yeah,
And
we have time.
we have time. Good.
We have lots of time. Lots of time. So anybody that's listening, I see all the participants down there. Feel free to type in your questions, and we can pause throughout the presentation and talk about it.
Yep. So let's go back here. And
Okay, I can see your screen now.
so I had this about how to achieve autonomy. Here it's a bit more of the same, right? Which it's put on a more engineering type of chart where what I mentioned before is the driving environment, are the streets, is the weather, are the people, are the bicycle riders, and the cops drive in the middle of intersection where the traffic light broke, and the traffic signs and everything else, right? Um, Now you have the sensors, you have the V2V, which is vehicle to vehicle communication, and you have the actuators. I mentioned earlier, it's your steering wheel and the pedals, or not necessarily the pedals, because the car doesn't move the pedals, has motors, which are steering, and has pumps, which are braking, right? There are a few things of, how can I say, few types of processing you have to do, and activities you have to do, right? Which is, of course, perception, planning, and control. What they mean, it's environmental perceptions. The car has to be aware of the surroundings and where it is. Now, based on this, has a mission planning, so the car has to go from point A to point B. It's a behavior planning, like slow down or I move faster, or or no, and more like I have to signal left or I have to signal right or I have to turn on my headlights if it gets dark, right? It's motion planning, which is the left and right, and faster or slower. And then is the control, and the control moves the actuators, and then it's actually follows the path, or the car draws the trajectory, and then it follows. So this is about the This is pretty much the same thing in another way of explaining the control architecture. I won't stay too much in here, and I'm gonna give you an example of what goes into. And this is taken from the website of the company called Aptiv, which is one of the current leaders on autonomous driving. So you have the car, you have 9 lidar sensors, you have about 10 radar sensor. We have a few cameras. This trifocal camera is something that you can see even today on the cars that have, the automatic cruise control and automatic braking feature, which is either a dual camera or a trifocal camera, and it's used also for being able to triangulate and measure the distance, where a better sensor for measuring the distance is the LiDAR. We have connection to GPS antennas. We have a connection to this DSRC. What it is something that United States and other countries are planning to introduce on the infrastructure along the highways and along the roads, which are kind of connection points for the car. Yeah, I think it's a 5.9 gigahertz frequency. You connect to that, and through that you can talk with the world. And they're going to be spread along the roads. So at any point, the car can talk and they can talk with maybe other cars. Why other cars? Because there isn't a standardization nowadays. I mean, Toyota can make cars some way, and on the other hand, you have an American company, and those guys will never make the two cars to talk to each other. So you need a third party, and this can be happening from this DSRC standard. Right? Also, you can talk with infrastructure. You can get information in advance that you might have, the road blocked or obstacle on the road, and you can plan an alternate trajectory.
I had a quick question.
Uh-huh.
Okay, so something that you said that was interesting to me because it translates to so many other technologies and things that we have. So if one car maker is making one type of a autonomous car, and then you have another car maker they will not be able to usually communicate together. So you have a third party so that you can have some sort of connection with everything.
Well, this is what
that's what you were saying.
Yes, and this is what we see today. This is what we see today because of the lack of standardization in the industry. Because we have a few big players, each of them doing its own, and then the government, I think they were the governments or some international bodies launched this standard, which is called Dedicated Short Range Communication, DSRC. It can be used as a as a communication medium between the cars. Now, in the future, when 99% of the cars on the road, some say this future is not too far. 99% of the cars will be autonomous. I think the designers and manufacturers of those cars will be smart enough to come to an agreement to standardize the communication in between the cars.
Yeah, I guess it's just in the beginning. Everyone sort of has to itself. I've seen this in amateur radio and other, of course, industries as well. But hopefully down the road, when you have a huge population of them, then some things will become more standardized so that they can connect and talk to each other. But anyway, I was hoping that might happen a little bit sooner.
And
wishful thinking on my part.
Yeah, no, it's actually not necessarily wishful thinking because the market pressure will drive to that, right? Or the consumer pressure will drive to that. Like if it's enough for two full autonomous cars to hit each other, and some loss would happen, and then experts to figure out that if they had a way
Exactly.
that the two cars talk to each other to avoid it, next day is gonna be a law
I
mandating
definitely think
that.
it's I definitely think it's in their best interest in the
Yeah,
long run, but that's just my thoughts on
yeah,
it.
no, I fully agree. So you can see how all this are spread around the body of the vehicle. And interesting enough, two computers and software stacks. This is for functional safety, for redundancy. Like one fails, the other one take over. And there are different ways of achieving this. It's either full 1+1 redundancy, is both doing the same thing in the same time, and then you have kind of an arbiter that decides whose data to use to control the car, or is one does the job and the other one takes over when the first one fails. There are different type of strategies, right? But it's interesting enough that what I've seen so far, it was pretty much redundancy on actually the main part of the system that does the recognition, the classification, the planning, and the decision. Uh, I did add a slide here about the lidars because I assume that everybody is familiar with radars, right? And familiar with cameras as sensors. I didn't know how many are familiar with the lidar. And so what the lidar is, a light detection and ranging, and it's pretty much based on the same principle like the radar. Radar actually you send an electromagnetic wave, and then it reflects and you receive it back, and you can calculate the distance to the object, for example, and the speed of the object. Um, LiDAR is the same thing, but it's based on light. It's based on laser light. It has um, like source for the laser and the receiver and some mirrors inside and some lenses, and it's extremely precise in measuring distances and actually creating some kind of image of the reality. So I put up here a picture of how we can recompose. Of course, it's a rendering on a computer screen, the image that the lidar see. Um, Now, the main piece, and this is actually something that I've been working for the past couple of years on. It's the main computer. Now, the picture here shows one of the early models, which looks more like an engineering type of benchtop, jacked up to be able to drive around. Um, and I believe because it was a public picture, I couldn't share, some IP that I know that companies are working on recently. Um, but pretty much imagine all this hardware here at the back being compacted in a box, which is maybe half-meter by half-meter by about 25 centimeters or so, right? I mentioned very high power in the kilowatts range. Of course, active cooling, fluid, liquid cooling. Now, why? Because typically what we're seeing on one of these computers, they are the CPUs, and I listed some names that everybody knows, like Intel and AMD and Qualcomm. And then an example of a CPU that I've seen used in this kind of application, it's an Intel Xeon Platinum, which has a 56 cores and 9 teraflops, single precision performance. Teraflops, I think, is um, if I'm not mistaken, this refers to the operations per second. It's floating point or operations per second. Um, we have GPUs, which we are familiar with from the gaming computers. Now, what these are doing on the gaming computers are, crunching numbers for images, for videos. This, in the case of the GPUs used in autonomous driving, they're pretty much crunching numbers. They are mostly used. They are the processor used mostly for the recognition part and the classification part. They have this one of the example I use here. It's the NVIDIA Tesla V100 has 640 deep learning tensor cores. What is this tensor cores? Tensor cores, sorry, are pretty much massive artificial neural networks, and each of them, well, total performance of this tensor cores are 125 teraflop. Other types of ICs here, FPGAs, of course, maybe everybody heard of Xilinx and Altera, ASICs, which is application specific integrated circuit, like Tesla is developing one for itself. It's Ambarella, it's Mobileye. Now, interestingly enough, what actually I wanted to get to is the fact that the human brain, the estimated performance of a human brain is 1 petaflop. This is what I've seen in some studies. Oh, this is flops, not. Give me a second, flops. Flops. So what I wanted to show here, if we actually, the way I see it, it's like you use a few of these GPUs per system, right? You use at least a couple of Intel CPUs. You use all the other computing integrated circuits. If you add everything up, we end up with about 500 terafloating point operation per second, which means pretty much one computer for autonomous driving has about half. At this moment, I mean, you will see how the future takes us, but at this moment, typically one of these computers has about half of the processing power of the brain, human brain itself. Which is pretty amazing. Now, the problem with this is when we drive as human drivers, I read some studies saying that we might not use maybe not even 1 or 2% of our brain capacity. And to be honest, switching back a little bit, I have a question. How much Heather, do you remember when you drive somewhere? Let's say commuting daily, going to job, and you get there. How much of the specifics you remember after you get there? The specific of driving.
Yes, actually a very good question, because there have been, I try to be mindful when driving, but I would be honest to say that oftentimes it becomes so automatic for me that I'll get to my destination, and if I tried to remember the whole driving experience, even though I remember driving safely there, you
don't remember
no memory of it.
Yeah, I don't remember much.
So, which is kind of scary.
Yeah, well, it's not scary because our and actually the point I'm trying to make, it's funny enough. When you drive, we use a small part of the brain which is wired to drive, right? we don't have the full conscience and attention to the road, right? Because we don't remember that. Right? Now, let's say 1% of that, right, of the brain capacity. Now, right now on the hardware level, trying to achieve full autonomy, and we are not there yet, right? We are using about a processing power which is, how can I say, which is half of the brain capacity. And it's pretty much not there. We are not there. We are still not, you know, we have not solved the autonomy problem. So it's very interesting. Is the hardware fault? I don't think. uh, I've seen a chart recently showing on the software efficiency on the airplanes versus autonomous cars, and autonomous cars are off the chart, like off the chart. I mean, the software is not, it's not there. So anyway, other questions so far?
Oh yes, let me get to the chat here, the Q&A. There were a couple questions. Okay, from Raluca. Thank you for your question, Raluca. So it says, hi, how much of these autonomous systems are in fact inspired from F1 cars? Because you say it's not enough, there's not enough standards, yet the models for the standards exist in F1.
Oh yeah. When I refer there are no standards, it's mostly no standards regulating or trying to how can I say, trying, when I refer to standard, it's not a typical technology used somewhere. Well, I refer most like regulation, right? I'm talking about international standards. I'm talking about international bodies, which are kind of regulating the use of the cars, how they communicate to each other, how they communicate to the road, to the infrastructure. Give you an example. General Motors had put a request with the National Transportation Safety Board in the United States to allow them to run on the roads cars without steering wheel and without pedals. And that has not been approved yet. The other one, it was a discussion. Meda. I'm enough. Okay, sorry, I'm getting the coffee.
Oh, that was so nice of them to bring you coffee during your presentation. Wonderful.
Yeah, thank you.
That was so kind.
Other things I remember, it was a discussion about who's allowed to run these cars on the street, and the big companies have been pushing the Congress to allow only the manufacturers that have, I know how many million miles already driven. So when I'm referring to the standard, I'm not referring to the technology, and the technology already exists. True. And Formula One is it's only one example. I mean, for Formula One, it's not an autonomous car, right? It's the driver. Yeah, it has a lot of technology, has a lot of sensors, and those sensors are used in the nowadays even autonomous cars. When I'm talking about standard, talking about regulating the development and trying to come with common direction and common ways of doing things in between the manufacturers or the players, the big players. So we don't have, two robots on the street that don't talk to each other, for example.
Yeah, I was going to add, and common ways of communicating with each other for that exact reason. So, which will, I think, inevitably just happen, but we hope sooner than later. Okay, I have another question, couple actually, if you're ready for them, we can.
Yeah, sure.
Okay, so Cornel Yukishu, thank you for your question coming to us, I know, from Canada. Do you consider, or have you considered, error correction systems?
Yes, I mean error correction systems less than as a system itself, but part of the algorithms which are used in autonomous driving, there are used error correction algorithms.
Mm-hmm.
So I'm not talking hardware systems, but I'm talking the algorithms, right? Um, and that can be different types of implementation, right?
Mm-hmm.
But I say the answer is yes, not necessarily the full system level, but mostly at the software level in the the algorithms that are used.
Well, that's good to know. That's good. Okay, another question here from Sandra. Thank you, Sandra, for your question. In reference to the DSRC communication antennas, will these be nodes? And as a follow-up, will there be any direction systems built into the roads and highways?
Yeah, currently in some parts of the United States there are. So the infrastructure already started to adopt this DSRC system, where what are these are, imagine a hotspot, right? Where you can go and connect with your cell phone or your laptop. This is
Right.
a hotspot where you connect, the car connects to. It's a specific frequency, is that I think 5.9 gigahertz. Now, the question is what type of information can be transmitted and received through this DSRC connection. But yeah, they exist and they are already implemented in some parts of United States along the highways.
Okay, that's a good question. As things are being built, where are they being built? And they're already being built. They blend into our natural environment sometimes.
Yeah,
That's the way
you
that
know, funny
we
enough,
like them.
because I talking about the SRC, they were created just because the bandwidth of the which existed a few years ago, talking about on the cell phone industry, was not enough for the volume of data that has to be exchanged uh, by the cars with the environment. And more recently on the 5G actually came. There were talks where the 5G supposed to kill the DSRC system because 5G offers enough bandwidth, and why you need the penalty of adding infrastructure to the roads when you can just use um, uh, you know
The 5G
connection from
spectrum.
your car, yeah, that many cars already have. So many of the new cars they have my car used to have a phone number associated with it, which I never enabled, but yeah. So it's interesting because at this moment we are at the point where the technology available out there, and talking about 5G might as well kill the DSRC.
Time will tell, for
Yeah.
sure. Okay, that's all the questions we have for now in the chat. So I'll turn it back over to you.
Okay, so let me go back to start sharing.
Okay, we can see your screen.
Yeah. So and I think we discussed a little bit, moving a bit away from the deep technical stuff. It's why, like why we should go for autonomous driving, right? And it's very interesting because there's studies being done where some say that will increase the road safety, reducing the accidents by 87%. Now, honestly, in a world where the full autonomous cars, the full self-driving cars will mix with the human drivers, the human driver will be the problem, right? So, but anyway, even though has been kind of estimated that the autonomous cars will reduce the accidents by 87%, the pollution by 66, and here it's a very interesting study where a lot of the pollution, even for the gas cars that we have right now, comes from congestions. You know, the big cities being, the traffic being congested, coming to very slow, or bump to bumper, coming to a stop, and all the cars continuously be burning gasoline. Where in a world where everything it's automated, um, the most of this traffic congestion will be eliminated, and most of these emissions will be eliminated, not necessarily from switching from gas to batteries, but by by eliminating the traffic congestion. Um, well, reducing on the need of the parking space, and of course, I mean, if you don't need to drive your car to work or drive your car to school or whatever, of course you don't need a parking spot, man. Traffic efficiency, 30% shorter commute, and I mentioned less congestion. This is a very interesting point where everyone will have access to equal access to transportation. Now we do have public transportation now, and we do that offers this, but at least I live in Detroit area, right, outside Detroit. Michigan as a whole is not designed for public transportation. People must have a car, and it's amazing that I look to the neighborhood, and almost every house has 2-3 cars, maybe even more, because everybody needs a car. Where in a case of accessibility to fleets of robotaxis, you don't need that anymore. Make transportation more affordable, boost productivity, and this, of course, a corporate dream, because they think that while you're driving to work, instead of spending 30 minutes driving the car, you can spend 30 minutes responding to emails. And moreover, you go there, you are completely relaxed, you can start working, you don't get pissed off waiting in traffic.
No, that does that. Some of that does actually make me a little bit nervous. Oh, you have more time to check your media platforms and email and.
Okay. Well, improve the
Driving has
overall
always offered just hopefully a little bit of time to not do those things.
Yeah. Well, you are totally correct. However, I found this as one of the benefits of
Boost
autonomous driving.
productivity. Yes, I saw. Mm-hmm. Mm-hmm.
And other stuff like efficient public transportation spending and improved overall reliability of the transportation system. Now, some numbers behind this. Past few years, 38,000 deaths caused by car accidents every year in US only, right? Applying that almost 90%, 87, 90% percentage of reduction in accidents or fatal accidents, we could save about 300,000 lives in a decade. Now, of course, not everybody dies in an accident, but many people get hurt. So it was calculated that whopping $190 billion saved in healthcare expenses, because the healthcare is expensive. Now the cars need to be fixed, right? $488 billion total savings from accident avoidance. $138 billion savings from congestion avoidance. And if you think about, we are spending about 100 minutes driving every day. This is 38,000 minutes a lifetime. I actually I didn't calculate in hours. That you can actually spend enjoying other activities while in the car. I mean, check your social media platforms, read a book. I would recommend the later.
I definitely could get behind, saving lives and the money on medical care for, for the accidents, and putting sort of the numbers right there in front of us and the reality of the numbers. That's significant.
Mm-hmm. Now, this was the why. Um, a little bit of a challenges, and this is actually moving into the topic if we should be afraid of that autonomous cars, and not only like what is the problem right now? What we're still, in my opinion, away from solving the autonomy problem. Well, it's the functional safety, it's the reliability in general of the electronic and software systems, right? That's why you've seen we have to use so many sensors because most of the sensors actually they're overlapping the information. It's just redundancy on the information, and and the computers, right? Now, of course, the computers you're using for autonomous driving is way more reliable than the ones that we are using at home. Uh, the operating system on those is not Windows because we don't have the luxury to do a Control Alt Delete and restart the computer and driving at, I don't know, 70 miles per hour on the highway. One other challenging is actually the cost. Right now, a system that similar with the one I showed earlier, all the sensors and the computers, it can cost more, and not can, it costs more than the base car. So that's why this will be intended for mobility services, for fleets of robotaxis, at least initially, until the cost is going to come down, um, well enough for the regular people to afford the car. If you ask me, I don't think I'll ever buy one of those. I'll use it, but I'll never buy because I still enjoy driving. So, yeah, maybe I'm gonna have a car, which is gonna be my fun car that's going around in my free time, right? But the cost for a full autonomous car right now is prohibitive. I would say for um, middle class. Now, a driver on cost right now is the hardware, and why I put here the death of Moore's law. Um, and for the people familiar with the electronic industry, I think this this Moore's law it's well known. It was postulated, I think, back in the 60s by the IBM chief at the time, who said that every year the number of transistors will double on the integrated circuits, and it actually stands true for more than 50 years, 60 years. Now, I read some recent articles where it says that actually Moore's law is dying because we reach the platform where the newest processors are built on a 7 nanometer platform, and many people say that's the limit of physics, because if you go more than 7 nanometers, you're gonna end up on quantum phenomenon, and the electrons going through it's gonna be like electron tunneling and all kind of other quantum phenomenon that will make impossible to control the flow of the electric current the way it's made now. So actually, I read an article about many people proclaim that the Moore law has died already because we cannot go further than 7 nanometers. Now, this Moore's law have been, I would say, or some say, the main driver of the economy growth and technology progress for the past 50, 60 years. And I brought it up here just because if Moore law is dying, that means the cost, well, improving the cost of the processors going into can be done through processes, the manufacturing processes, but we cannot pack in more processing power in the same chip, which means we need to go to similar Moore law on the software side, where where we need to make the software and the algorithms more and more and more efficient in order to reduce the total cost, the total hardware needs, and the total cost of the systems. I did talk about the lack of regulation and standardization. Liability. It's very interesting question. Is one of these autonomous cars will hit a person or another car driven by a human driver, or two of these cars will hit each other, whose fault is? It's the fault of the machine? Well, lawyers will never agree that it's machine fault, right? They have to find somebody at fault to pay the penalties. It's gonna be the guy who is operating the car in a robotaxi business model. I will say no, because I'm not controlling the way that the car is behaved. Will be the guys who built the computer, maybe. Will be the guys who designed the computer. I myself, maybe. I might end up in jail years from now. Uh, but I did read a very interesting article, a year or two ago, um, and the title was just this: Will the lawyers kill autonomous driving? Um, other uh, challenge is the current road infrastructure, because it's very easy to program autonomy, and you can recognize all the signs and recognize all the lines on the road. But as we know, there are many roads that don't have lines. There are many roads where the signs are missing. We know that are like um, dirt roads outside in the countryside. Um, it's still a challenge, right? For being able to go to level 5 autonomy, where it says the car is going to drive itself in all conditions. Environment, and here I'm talking about everything about weather, about heavy rain or heavy snow, about dust that can go on the lidars and cameras and blind them. But also I'm talking about road environment, where very interesting challenge. And I know one of the companies that work in the field have created a research group only for this. Is when our traffic lights are off, and you have a cop in the middle of intersection directing the traffic. Now, those gestures, so the gesture that the police officers make in the middle of intersection, are not standardized, right? We as human beings understand them because we've seen them, but imagine a car, imagine a computer trying to interpret what the police officer in the middle of the intersection tries to by moving his hands around, right? Um, and of course, one of the other problems, it's the human drivers and the ethical challenges. And I mentioned here the trolley problem. And I'm just curious to switching back a little bit to the video stream.
One thing that I thought was interesting is that, if there was to be a accident, there's usually somebody to take fault. And, I wonder if things would be bounced around as sometimes they are today, where, well, you'll have to, it was this person, it was this fault or fault of this, or, sometimes you get bounced around even nowadays. Well, you'll have to call that company. They're the ones in charge. Oh, no, call that company. They're the ones that should be handling that issue. And, oftentimes that's the case nowadays. So it could cause a little bit of some sticky situations, I imagine.
Yes, that's why actually the article I mentioned about the lawyers who kill autonomous driving was very interesting. Right? It can happen. But what I want to stay a little bit with is the trolley problem. It's one of the thought exercises that was created many years ago, and I don't know if you're aware of that, the trolley problem. Well, if not, at the time when that was created, it was like this: you have some trolley tracks and a trolley coming down, right? And at some point is a lever that you can change it's a bifurcation on the tracks, right? and it's a lever they can use to move the trolley on one way or to other way, and then you have some workers working on the road, right? And then on one of the tracks are like 5 workers, and on other track it's only 1 worker, and you realize that nobody sees that workers are there. Trolley doesn't have to, cannot stop in time, and for centrally will kill the people on the tracks, and then you are the only one who has to make a choice. And the question is, what you're gonna choose? You're gonna choose to kill the 1 guy, or you're gonna choose to kill the 5 guys? Well, interestingly enough, this in real life on the human drivers, most of the times when you are on the limit in an accident, you react instinctively, right? You don't think. Now the problem is that those cars will be put in a situation like, well, it's a old person crossing the street, right? And the car cannot stop in time because detected the person at the last minute, and it can make a left or a right, but there to the left, it's maybe a mother with a child, right? So what the car will choose? And the problem is that the car cannot choose by itself. Right? The car has to have programmed the choice. And actually, this is the ethical challenge that probably it's start manifesting itself, where the people programming those cars um, will have to make ethical choices. Huh? Any other questions? So far, I think we have about 30 minutes left, and just a few more slides I have, and I can probably go to more Q&As at the end.
I will have a question because I'm more into this field, and I'm curious regarding the security, but from the cybersecurity perspective of an autonomous car, because it's relying a lot on sensors, on radio, on Wi-Fi, on different kind of Bluetooth technology, low energy, high energy, and plenty of them. And a lot of sensors that are using per RFID per transmission, and in order to read or send information. All of us know that all these technologies have security glitches. The protocols have security issues, and they can be compromised. How's this part tackled from this perspective? Because if I can hack the car, then actually I can control it to do whatever I want with it. What
And
are
this is actually,
the limitation and the constraints?
well,
Thanks.
it was actually a similar question to the beginning. One of the very important requirements on developing this kind of system are the cybersecurity ones, right? And there are many ways of addressing it, right? We have, for example, Ethernet communication, right? One of these computers can have multiple Ethernet ports for talking with other parts of the car, right? Now, each of these, as I mentioned, what we do is it's called TARA, T-A-R-A. It's called it's threat analysis, and for the cybersecurity point of view, and you look at the box, and you look at all the environment, and you look at all the possible ways of getting in the box and hacking the box. Can be physical ways, because not necessarily you connect to it remotely, but you can actually steal one of these cards, right, and actually hack the computer itself. But it's also the remote access. And you take all this direct paths into the box, and understand how can be accessed and what are the dangers of accessing different different parts of the system or accessing the box through different communication paths. And then from here, you try to put layer upon layers upon layers of security. Can be software security, right? Meaning when you program or you try to upload the software on this one, you only, you use some, they call it secure root of trust. They are using keys. So each device is gonna have to talk with externally using the same key, like cryptographic keys, right? It can be used some hardware encryption devices or some hardware security modules. There are many examples of what is used to make this this box safe. And similarly with the functional safety, where you do a similar analysis, try to have input redundancy and make sure that you have a way of monitoring and reacting to any kind of failures. This is how actually you do on the cybersecurity. Right? I mean, it's not for nothing that one of the system costs more than a car, right? It's it's more than the even how can I say the typical solutions that are used in a consumer electronics industry. Okay, not sure if this answered your questions.
It's a good question.
Mm-hmm.
Yeah,
I think
thanks.
cybersecurity is
Okay.
on everyone's mind.
Yeah, it is. And I'm not saying that perfectly safe. I'm saying that everybody works toward making this as safe as possible. I think I had one. I think I skipped a couple slides, if you guys allow me to go back to them. And it was because I'm wondering why I went so far so fast. We did talk about the tensors and the deep learning. Well, usually this deep learning refers to large neural networks, which are used for mostly, let's say main categories is the object detection and the classification, the tracking, the scene segmentation, image classification, and driving lane detection. So again, if you take an image with a camera or with a Lidar, what we actually want to is, extract contours, for example, from the shape of the contours, detect what the object is, if it's a pedestrian, if it's pedestrian close, it's a pedestrian far, if it's someone on a bicycle, if it's a car, if it's a bus, whatever it is. So it's like building a knowledge of the reality. Right? For example, here it's actually it's classification. Yeah, this is an SUV, and this is this far away. Oh, this is a passenger car. This is a sport car. This is a police car, right? This is a truck. This is an example of detecting the traffic, the driving lane detection. And again, one of the challenges of not having these lines clearly on the asphalt. I mean, it's imagine how hard it is. And this last image here, interesting enough, is an image of the 360 LiDAR sensor, which is on top of the Waymo Waymo cars.
Sorry, Pompilian, but you are not sharing the screen.
Oh, I'm not sharing, sorry.
No worries.
Thanks for letting me know. I was just talking about where it is, share the screen. Okay. Let me go here. Happens to me sometimes.
All right, we can see your screen.
Yeah, that's
yep.
Great.
So I won't tell the story again, but people, cars, buses, pedestrians, bicycles, far and close, right? Type of cars. lane detection, and color coding, right? Sky, building, pole, road marking, road, pavement. Oh, this is the scene segmentation and classification. And well, this is what we do in our brains when we drive, but we do it without being aware of. Let me put it this way. And this is actually an image which is taken from the right bottom corner. It's an image taken from and it's superimposed image, right? So this is from the top of the car with the camera, and this boxes with the colors is actually how the Lidar used on the top of a Waymo car is classifying and measuring the distances to the object. Now, without spending too much time on the software side, which is not necessarily in my field, but I did neural networks in university. A little bit of this is pretty much the base. There are other methods used, and everybody knows about evolutionary algorithms or genetic algorithms. And I did read recently a book about the fathers of they call it electronic brain, Hugo de Garis. It was in the 90s when he used FPGAs to build an electronic brain, and he used neural networks implemented in FPGAs and actually genetic algorithms to grow these neural networks. And it was a very interesting way of doing it. Right? But what are the neural networks? Are pretty much computing nodes or computing systems which are inspired by the human or the animal brains, human neurons. Each of them, like a neuron, has multiple inputs and has an output that connects to other neurons. It has a mathematical function that calculates on the inputs to generate an output, and you pretty much connect this in multiple layers. And you have some information fed on the first layer, and then you train. These are a lot used for pattern recognition, which is pretty much the base of the image classification and recognition, right? And you drive around millions and millions of miles, and you take millions and millions of images, and you train these neural networks to recognize pedestrian, to recognize a car, to recognize a traffic sign, to recognize a line on the street. Now, this is was a little bit about which I somehow escaped in the presentation. Challenges. I went through this, and a few questions here. Right? Initial question: why we would be afraid? Of course, basic question for everybody.
Yeah, that's
would
a
you trust?
good question.
Would you trust a car? Yeah.
Why
So,
why should we be afraid?
Yeah. So, would you trust a car that has no driver, no steering wheel, no acceleration, no brakes? And think about if you would be inside the car or outside the car.
That's actually a good point. That's another level. Even if I'm outside of the car, walking on the sidewalk or whatever, or riding my bicycle.
Honestly, when it was a couple of years.
For me, I got chills on my skin. I'm going to let someone else answer that question. My instinct says no, but
let me tell you a story. I was a few years back in Germany driving. I don't remember. It was anyway. I was going to Frankfurt airport, and I passed a column of Mercedes trucks. I have been 5 or 6 of them, and funny enough, only the front one had a few guys in the cabin, and one of the steering wheel, and a couple of other guys having a laptop or something, and all the other trucks driving, behind. I had nobody in the cabin. And I passed, and I noticed that, and then instantaneously my hand got goosebumps. um,
You grab the steering wheel just a little bit more.
yeah, let me speed up and pass all the column as fast as possible. But then was
I saw
driving
it
by.
on the news. They were doing with truckers and truck driving, you know, and going across the country. And these trucks may have already passed you, and there's nobody in them, and you can't even you can't see. You're sitting way lower than they are. This is already
But you
happening.
know, my second thought was after the goosebumps is, what do you think would happen if I actually get in between, in the middle of those tracks? They will still be able to follow each other.
Hmm.
And and
This
of
is
course I
something you
didn't do
didn't
that.
try, though, right?
No, I didn't.
Well, you're here telling the story, so either way, it
Yeah.
worked out.
And now I talked about the cars being hacked, and we talked about cybersecurity.
Yeah.
We have to be aware of the count as job losses. Right? Think
That's a
about
good
that
point.
everything that means delivery service right now or mobility service right now, the jobs will be lost.
Yeah.
Um,
And I don't know if somebody's talked about, you know, the job loss versus the jobs gained, you know.
oh, there are jobs gained, that's for
There will
sure.
be jobs gained, and there'll be jobs gained who becomes that third party interface to allow communications between different systems. That's going to be a whole nother needed job.
And
But
are the jobs to design these cars? Like um,
right.
from my own
Is
experience,
there
my
a
team right
balance?
now,
You know?
yeah, my team right now only to design the hardware of this type of a computer. It's anywhere between 100 and 150 engineers. But these jobs will be highly qualified jobs. Will be the people that program these cars, and we can count them on thousands. So it will be highly qualified jobs. So I mean, the future is near. I recommend that everybody who's still at a younger age to not plan of becoming a driver and going to university and trying to becoming a software programmer or maybe an electronics engineer.
Absolutely. I think
Uh,
it's going to be a whole new industry for you know, for young people just starting college or thinking about their future careers or something. As all this is being developed, I mean, who knows what kind of jobs are going to be created that we aren't even aware of that we need through all of this, you know?
yeah.
That's going to be the
And
future.
the last 2 points here. It's how can you program a car to make moral decisions? And we talked about that. Um, and a very interesting point is if the governments will ban or limit the use of human-driven cars. And it's a very interesting point because again, when the majority of, or not, let's say half and half split on the roads between self-driving cars and regular cars, the human rights will be the problem. I mean, even now, most of the collisions that the self-driving cars got involved into, they ended up being you know the fault being with the drivers of the other cars. And now, if you think of the billions and the billions and the billions of the dollars of the benefits, uh, we might get to a point where the government will ban or limit the use of the human driving cars. And the interesting thing is, I did really read recently a story by Isaac Asimov. It's called Sally, um, and it talks about conscious cars, autonomous cars that become conscious. Funny enough, actually, he puts the first car, full autonomous cars in 2015. The story was written in 1950 something, 50 or 60, 63 or something, or 57. I don't remember exactly when. But he puts the first autonomous car in 2015, which remember the Google the Google car, the little buggy, and then he mentions in his story that at some point the government decided to ban all the other cars just because you know, all this benefits for saving lives, reducing the expenses, um, reducing congestions and so forth. So no, maybe we should be afraid of the autonomous cars because they will replace us as drivers. What the future holds, this is a very, very condensed chart, which pretty much take us from the history all the way to 2020. But what the future holds is actually the fact that it is projected that by year 2035, which is not too far away, it's 15 years from now, there will be 35 million autonomous cars on the roads. Again, talking about the level 4 plus. And majority of them will be in Asia Pacific. And as you can see, like right now, there are not too many of them. There are only test cars operated by the main players I mentioned earlier. But it will start growing as of 2023, and it's gonna grow pretty quickly. And I'd be surprised if the adoption is gonna happen faster, and people will be able to solve the cost problem and the full autonomy problem. We might see the numbers going even higher. And I think this is the end of the presentation I prepared. Yeah, thank you all. If you want to contact me, this is my email address, and you can send me questions afterwards. But then I actually can go back to stop sharing and spend the last 15 minutes just discussing if anybody has any other questions.
I saw a question on the chat. Why do you need so many T-flops?
Oh, just because, as I said, the full autonomy problem is not solved right now, right? Think about that. Let's say a regular image taken by your phone has right now, by the modern phones, have close to what, 20 megapixels, right? Well, the images that are captured by the cameras, by the car cameras, not that high because it's a physics question. If you try to have them working at the lower light or nighttime or lower light, it's compromised in between the resolution of the sensor, the quality of the image. But still, we are talking about few megapixels, even close to 16 megapixels for a picture which is static image. Now a video, it's a suite of frames. Now, in order to process with enough accuracy and detect movement, you can collect anywhere between 15 to 30 to even 40 or 60 frames per second. So you multiply the data into a frame with the number of frames, and only in a second, right? Now, this is a continuous stream only from the cameras. If you have at least, I don't know, I think I showed earlier, we can have up to 3, 4, 5, 6 cameras. Tesla actually does their level 2/3 only with cameras. Some of these systems I've seen up to 12, 16 cameras, you can imagine how much is the quantity of information that you need to process. And that's why you derive the T-flops. And it's again, you have to do recognition and classification and then decision. Plus that you have other type of sensors, Lidars, which are similarly like an image with the ones that you take from the cameras. And we counted, I don't know, about 10 of them. And you have radars, and you have ultrasonics, and you have microphones, and you have, and again, as I mentioned, the software, it's still not very efficient now. So we can get to where the brain, it's using only a little portion of its 1 petaflop to drive, but at this point, where the technology is and where the algorithms available out there, we are still throwing as much processing power as possible until the autonomy problem is solved, and then I think next step is going to be optimization, where maybe you don't need close to, I don't know, 500 teraflops to drive a car around. You can maybe do it with 100.
So Pompilian, good presentation, good topics. Of course, you have been in Altantykron long time ago, in 90s. But
yep,
after
my
that,
last year was 95.
okay, but from 2000 we start talking, and youth has a chance to be in contact with the scientist and to find new technology, to hear about new technologies, including about autonomous cars. Of course, science fiction ideas, which, you know, ideas come to be true in the real life.
Yep.
But because you were in love with the science fiction from the youngest, right? When you were young, this help you in your thinking, in your job, because also you are a science fiction writer. How this works together?
It's a really good question, Soren. Thanks for asking it. It's actually, I don't know what to make the demarcation and the thought process. Now, what science fiction helped me with is to keep my mind open all the time and open to new ideas and new solutions, and not get the attitude that's, well, something like this, it's impossible. Right? It's every challenge I get in my professional work, the impossible doesn't exist, right? And this probably comes from the fact that I've been a sci-fi fan, and I've been a sci-fi writer, and I actually managed to publish my first book last year, collect all my old stories in a volume. But yeah, this is, I think, what it helps me. It's on the professional work. When I have challenges and somebody comes and says it's impossible, it helps me to be strong enough to understand that nothing is impossible.
Okay, thank you. I want to ask you just a favor before to close. Let's switch in Romanian.
Yeah,
Sandra, okay. I know you're watching us. Sandra Sabatini is a friend of Altantykron. She's from California. As I know, she's our friend, but we switch in Romanian because a lot of participants are Romanians. One of them, his name is Călin Giurgiu. Is something for you? His name, say something for you? Călin Giurgiu?
Oh, yeah. Of course he is. I mean, dacă mergem la românești, dacă ne aude, sigur că ne-am întâlnit, de fapt, în Statele Unite sunt de vreo 2 ani. Înainte de asta am trăit în Canada pentru vreo 13-14 ani. Călin e și el în Canada și ne-am întâlnit în Montreal și ținem legătura în permanență.
Vezi că astăzi am avut bucuria să o și vedem. Nu știu dacă tu ai văzut-o pe Nina Munteanu. Nina Munteanu este român, canadiancă-româncă, cum spune și numele, scriitoare de science fiction. A publicat 2 cărți în România, e specialistă în apă. în apă, specialistă în legătură cu apa, sau cum să o numesc, să nu greșesc, că este specialist care studiază apa și a avut o prezentare foarte interesantă, o conferință de vreo oră și jumătate aproape, foarte interesant. La propunerea domnului Florin Munteanu m-am bucurat. I-am vorbit de dumneata și de Claudiu Murgan. Apropo că nu știu dacă e Claudiu cu noi acum sau un alt Claudiu, dar Claudiu Murgan a fost mai devreme pe partea de science fiction. El a lansat niște cărți la prietenul vostru comun, al nostru comun, Pavel Constantin.
Da, Cătălin, da.
E și mai tânărul decât tine, Traian Bădulescu, cred că îl știi și pe el.
Da, știu și pe Traian, că doar ne întâlneam pe vremuri în tabără.
Așa. Bun, acum o întrebare tehnică legată de autonomie. Problema mare a mașinilor nu autonome. Mașinilor electrice sunt mai bine. Până la urmă, mașinile, zic eu, electrice vor avea șanse de izbândă mai mari decât cele pe zice, nu? Folosind motor cu ardere.
Da. Adică dacă ne uităm astăzi la toate companiile mari care produc mașini, cam toate se...
Bun, ce face cu instrumentul sau cu obiectul care înmagazinează electricitatea? Pentru că el e problema noastră. Cum crezi?
Asta e o întrebare foarte bună. De fapt, sunt multe aspecte. Mașinile electrice sunt considerate mai bune pentru environment pentru că nu ard benzină. Da? În schimb, bateriile care sunt folosite, cel puțin în trecut, erau foarte murdare. Știi? Bateriile pe bază de acid și plumb. Da? Acum, ele au evoluat. Sunt lithium-based battery, dar still sunt scumpe și eficiența de a înmagazina energie nu e acolo. De asta vorbeam mai devreme, sunt companii mari care pun sute și sute de milioane de dolari în cercetare pentru a putea veni cu noi tehnologii de magazinare a energiei electrice.
Hai să spun că în România avem câteva centre, unul dintre ele este la Râmnicu Vâlcea, centre care se ocupă cu studierea, cercetarea pe partea de magazinare de energie electrică. Este la X Râmnicu Vâlcea, nu știu dacă știi despre ei. Acolo s-a făcut, spre exemplu, la X Râmnicu Vâlcea s-au făcut, între altele, cercetări și s-a brevetat apa grea pentru centrala de la Cernavodă, dar au și alte proiecte legate de apă, inclusiv apă ușoară, da? Inclusiv aceea, dacă știi termenul, știi definiția apă vie, apă moartă, mă rog, acolo au și așa ceva, deci cercetări în zona asta, dar au și cercetare vis-a-vis de instrumente, cum se numesc ele, dispozitive care să magazineze energie electrică, tocmai pentru mașinile electrice. Și sigur, de aici mergem și mai departe către ce ai vorbit în seara aceasta, către mașinile autonome.
Cum am zis mai devreme, ce am văzut până acum, că toți care lucrează în domeniul ăsta cu mașini autonome, majoritatea mașinilor care sunt folosite sunt mașini electrice. Și cum ziceam, un computer de genul ăsta sau cu tot sistemul poate să ardă 1500, 200, 2000 de wați, 3000 de wați, ceea ce e enorm, pentru o mașină electrică enorm. Necesitatea de a avea soluții mult mai eficiente de a magazina energia e mai ales pentru mașini autonome este prezentă. Și sunt companii ca și Tesla sau alții care investesc sute de milioane de dolari în asta. Nu e numai cantitatea de energie care trebuie magazinată sau eficiența. Gândește că bateriile cântăresc. Da? Pentru fiecare baterie pe care o adaugi la mașină ca să poată duce 1 kilometru mai mult sau 10 km mai mult, o parte din energia pe care mașina o consumă este ca să care bateria.
Bun,
deci ne uităm la tehnologii noi, la eficiență, la masă, la multe alte, motive.
Nu știu dacă ai avut timp, nu știu dacă ai reușit să vezi, dar poți vedea înregistrarea. Zilele trecute am fost în direct cu prietenii noștri de la NASA, cu Ravi Prakesh și Risa Secley, și am vorbit cu ei despre, printre altele, despre ultimul rover care a plecat pe 30 iulie către Marte. Bun, și am întrebat, sigur știam despre chestia asta, dar am întrebat propulsia roverului, cum e asigurată. Și cum e asigurată? Tehnologie nucleară. Adică Departamentul pentru Energie al SUA, că ești american acum, stai acolo.
Da. Da.
Deci vorbim de tehnologie, da? Stăpânesc acea tehnologie ca acel rover, acea mașină să se poată deplasa cu ajutorul, are are și solar și nuclear, dar are este o tehnologie care permite transformarea din energie nucleară în energie electrică și permite autonomie roverului, ceva fantastic, dar pentru următoarele ani de zile pentru a-și face principalul obiect. Apropo de ce urmează, sigur că scriitori science fiction, îți aduc aminte în tinerețea noastră când vedeam Star Trek-ul, nu, când scoteau de acolo acea baterie, nu? Venea un inginer, mă rog, cine era acolo, membru echipajului, scotea, schimba bateria, nu? Era un dispozitiv așa alb, dar cine știe, poate și nu va mai dura mult. Câte idei science fiction au devenit realitate? Apropo de ceea ce faci tu acum, îți aduce aminte când ai citit tu prima dată despre mașini autonome sau ceva legat de ceea ce faci tu acum? Apropo de... Este incredibil până la urmă, dacă ție spunea Aurel Cărășel în anii 90, când eram noi acolo tineri și îți spunea că tu vei lucra în așa ceva, cred că nu credeai. Nu?
Sincer, nu. Nici măcar dacă îmi spunea Aurel acum 30 de ani, dar nici măcar să zic că acum 15 ani când am plecat din țară, n-aș fi crezut că o să ajung să lucrez. Da, chiar în țară lucram în domeniul electronice pentru auto, știi? Dar să lucrez pe mașini autonome, complet autonome, e într-adevăr ceva, cum să zic, care nu m-am gândit niciodată. Sunt unii care zic că astea o să ajungă să fie probabil la un punct una dintre cele mai mari evoluții ale tehnologiei pentru secolul ăsta. Vom vedea. Dar într-adevăr este ceva nemaipomenit și e ceva, cum vorbeam cu niște prieteni și ziceam, zic, când o să ajung la pensie și o să am nepoții pe genunchi, pot să le spun, bunicul vostru a fost cel care a pus mâna pe primul computer care a condus o mașină singură. Și e o chestie care, într-adevăr, numai pentru asta, plus pentru cărțile care probabil o să le mai și public în viitor, merită să trăiești, nu?
Te felicit pentru ceea ce faci. Îți mulțumesc că ai acceptat să fii alături de noi. Îi văd acum, îl văd și pe Călin Giurgiu în cameră cu noi, în cameră însemnând în acest room, la Zoom. Călin, dacă ne auzi, dă-i un unmute. Călin Giurgiu. Heather, if you have any question for our friends, Mihai, also, if you have any other questions for our friends.
Eu doar să vă salut. Ciao.
It's always good when I unmute. I've had so many questions along the line of this conversation, and I'm sorry that my computer must be afraid of autonomous cars because it kind of just bleeped out for a while.
It didn't scare everybody on the call.
Anyway, no, it's just been wonderful. What a learning experience for me. It's a little bit out of my world of understanding, but it's good to think of everything that's happening and thank you for everything that you do, and just for everyone out there, these are our future, so keep our eyes on the road.
Yeah, well, keep our eyes on the road until the point where we won't need to keep our eyes on the road anymore. Well, hopefully that those machines that will dream for us are still far, far away. I hope they will never be invented.
Yeah, but anyway, it's been a wonderful experience for me here, and a lot of learning, and we're going to continue to share the presentations. So I think that it's gonna be really popular and really interesting to watch. So
yeah, because we switch in English. Sandra Sabatini, do you have any questions for our Romanian friends which are living in Canada? You can unmute and you can put the question.
I'm just grateful
Sandra?
for the opportunity to be able to view your presentation today. And thank you for answering my questions about the news.
Well, I'm glad again. I'm very happy to be here. I'd like to thank again Sorin for inviting me. and actually Mr. Corneliu Kishu for contacting me and discussing this idea with me. And yeah, Sandra, I hope I answered your questions. If not, again, I did show my my email address earlier. It's tpompilian@gmail.com, and yeah, feel free to anybody can feel free to, if they are interested in the field, to continue the conversation on the email.
Mr. Radu Dop, any question? For sure that we have one. Dr. Dop? Dr. Dop, it's our visionary person. You don't have a chance to meet.
No. I have glasses.
Now, I know you are modest, but your contribution in time for what we build, what we already, or what we have built in Altantykron, Pompilian, it's one of our, let's say, we were so teenager in 1993, 1992, 1994. And as you see, also he's a science fiction writer. It's something, maybe he did that because he was in love with the science fiction. Because success. He's also visionary and he dreamed.
So I moved from writing science fiction to doing science fiction. Right?
Yeah. The border between are very, very unclear and difficult to be defined. But I think that we should think if the terrestrial transportation should be so important like we believe today. The new tendency to develop human communities, which are now concentrated in the big cities, maybe in future we can, having this challenge from the pandemics, we try to, and we prove that we can stay at home and to provide our contribution, social contribution, not changing places, destroying the space and using better the time. I think that transportation should have another dimension by hydro or by air, and terrestrial transportation for individuals should be decreased in next 10, 15 years dramatically.
Actually, I fully agree, and there is some interesting research. Research is done in moving away from autonomous cars to autonomous drones for transportation, which, if you think about it, it's easier to solve as a problem because those type of vehicles, aerial vehicles, can move in 3D, not in 2D, right? They are not constrained by predefined roads. However, that technology still seems a bit down the road, far away, but you never know. I mean, this technology of self-driving cars 15 years ago was non-existent. So you're right.
I think that we should discuss about transportation, not specifically terrestrial transportation.
It seems like a very interesting subject, and it's something that I had contact with, not expert level, but part of the mobility problem in general. We'll be looking into not only terrestrial, but I should say other means of transportation. It might be a subject for next year, maybe a roundtable for next year.
Use the other side of your human being, using your mind, and find in the science fiction territory space, find solutions.
Well, we'll see. right now, I have to do whatever pays my bills. So, career-wise, right? Unfortunately, but yeah, I'm free to write whatever I can. I want.
You see, we are defining the men of future. Have to be very professional and have to be a very, very deep dreamer.
Okay.
Yep. I think anyway, I do have to go back to my daily job, and again, I very much appreciate the invitation, Soren. It was a wonderful discussion and a wonderful opportunity for me to kind of share a little bit of my recent experience. And yeah,
don't be selfish. Share with your people when you grow up. Bring your contribution from the country you are born. And only speaking, only being in contact with the people. I'm happy. I bring you I bring you back. I'm happy to say that I bring you back. We have so many common things, and I'm sure it doesn't matter where are you. Even if you just talk, even if you just say, you can change minds. You can change things. And we are living in a so small world. As everybody see, we already start looking for another stars and other planets to go. It's still time for that. But anyway, we are living in a small world.
I'm glad to be back to Altantykron 25 years later. Right?
Tell to your children about
Sorin, don't matter where we are physically,
yes.
but we are belonging to the space where we are coming in this world.
Exactly.
That means the first drop of water which we have drank it from our mothers, first breath which we take in on the birth. These are defining us like human beings for the whole life.
Yeah.
Yep.
Actually,
Thank you very much.
Yeah, I was looking forward to this year. I was planning to come to Romania again, and I wanted to schedule my trip to somehow overlap with the Altantykron, because last year I was just before the Altantykron started, and yeah, unfortunately, what happened, and all of us know. But I'm glad that I joined the Altantykron this year virtually.
Okay.
But being close to all friends, it's always wonderful.
The spirit must go on. Even the spirit must go on. It's another step, our new horizons. Thank you, gentlemen. Thank you, Pompilian, for joining us. Mulțumesc lui Pompilian Tofilescu, de care mă leagă multe lucruri, special legate de Altantykron, dar înainte de Altantykron noi am fost împreună în multe locuri în țară ca și iubitori de genului science fiction, membri ai unor cluburi de SF. Eu eram la Atlantic Navodă, Pompilian era la Aricoan de Craiova, vremuri extraordinare, dar cert este că pe amândoi ne-a îndrumat în viitor acest gen literar și acest spirit al science fiction-ului, îndrumați mai mult sau mai puțin unii dintre noi, mai mult eu, nu știu Pompilian cât de mult, dar Aurel Cărășel a fost mentorul meu, sigur Alexandru Mironov, și iată că din ceea ce au ei ca vizionari, ceea ce au